Hi everyone, we're going to start some algebra proofs today. I'm looking forward to it. I hope you are too. Before we get into that, we need to review some properties. There are actually 9 of them, so I'll try to go through them fast. If I'm going too fast, feel free to pause it. These first 4 are all properties of equality, and for them, I know you've worked with them last year in algebra. You might not remember their names, but they should be pretty obvious. The first one says if you have something that's equal, let's say A equals B, and that could stand for anything, then what you can do is you can add the same thing to each side of the equation and keep it equivalent. So here it is with symbols. Here's how you used this last year in Algebra 1. You might have had something like x minus 2 equals 5, and then your teacher told you you needed to solve this for x. Well, then what you would do is you could add 2 to each side, and since you're adding it to both sides of the equation, that's okay to do. It doesn't change it. So you solved it to get x equal to 7. So we did this a lot with numbers in algebra. In geometry, we could add angles to each side. We could have segments to each side. We could add anything that's equal to each side of the equation. And if we do that, that's called the addition property of equality. I'll go through these next ones fairly fast. In the subtraction property of equality, you start with something that's equal, like A equals B. Then what you can do is you can subtract the same thing from each side of that equation. In the multiplication property of equality, you start with something that's equal, like A equals B. Then what you can do is you can multiply by something that's equivalent to each side of the equation, and you have another true equation. And if you couldn't guess what the division property of equality is yet, I'll tell you, but you can divide the same thing to each side of something that's equal, like, and we're just using A equals B, and that would be equivalent also. So maybe an example for like how you would see this in geometry, a little different than Algebra 1, you might have like 2 times the measure of angle C equals 50 degrees. Well, you could divide each side by 2. So just say that the measure of angle C equals 25 degrees. Well, that would be the division property of equality, because what you're doing is dividing the same number by each side. Okay, and the other properties here, what we have is we have the reflexive property. For the reflexive property, it just simply says that things are equal to themselves. So the way the book puts it is they say that A equals A. The way you'll see this in geometry is you might see that angle C is congruent to angle C, or the length of segment AB is equal to the length of segment AB. Whenever you have the exact same thing equal to itself, or congruent to itself, that's going to be the reflexive property. The next one is symmetric. For symmetric, you actually have to have 2 equations. So you might have if A equals B, then B equals A. And I know you use this all the time in algebra. You probably never called it the symmetric property in algebra, but I can guarantee you've done this lots of times without even maybe realizing it. So if I asked you to solve something like 7 equals x minus 5, well, what you would do is you would add 5 to each side. So you're using the addition property of equality. And then my guess is you probably said that x equals 12. And that would be correct. But technically speaking, what you have here is you have 12 equal to x. And you just flip-flop that around, and that is totally okay to do. And you were maybe not even realizing it, but you were using the symmetric property of equality in this case. The next one, you might not have a whole lot of experience with like you do these other things. The transitive property says that if A equals B and B equals C, then A equals C. So what you have to have with the transitive property is you have to have 2 things that you know to begin with, and then you basically like take those two middle parts out, and you can just say that the first thing is equal to the last thing. Or we could use this with congruency. We can do this with equality or congruency. I'm just kind of giving you the overall, this is the transitive property. What you're looking for is you're looking for one thing to equal a second thing, that second thing to equal a third thing, and you say that the first is equal to the last. For substitution, you have to have something that's equal to begin with also. So like if A equals B, then what you can do is you can replace, A can replace B in any expression or equation. So for example, a way that you use substitution in algebra is maybe you knew that A equals 7 and you were asked to evaluate like A squared minus 5. So you use substitution to substitute that, to plug it in its place. We'll be doing the same thing, but now maybe with angles or segments, or maybe they'll just be numbers like this one also. Okay, and then the last one, the distributive property, you should be extra familiar with, and you should definitely know the name of this one. The distributive property is when you have a number multiplied by a quantity, and then you multiply everything inside of those parentheses by that given number. So A, B, and then it'd be plus A times C. Here's one of the ways that we're going to use this in this lesson. So we're going to be asked to begin with writing some algebra two-column proofs. And these two-column proofs are basically like what they sound like. You're going to have two columns. So you can make just kind of a really big T. And on the left side, we're going to write our statements. And on the right side, we're going to write the reasons for those statements. When you were in algebra, you basically, when you showed your work, like your teacher probably asked you to do, you filled in this statements column without even knowing it. So the first thing you'd have to do is you'd have to write out the equation. So it says here that we are given that 2 times the quantity x minus 8 plus 3x is equal to 9. And that's what we were given. And then it tells us what we want to prove. So we need to list out the steps in order to get to where we want to be when we prove it. And what I'm going to do off to the side after we go through and do the algebra work is we're going to go back and write the reasons for those things. So the first thing I need to do to solve this for x is I just go ahead and distribute. So I'm going to write down that my next line of work is 2x minus 16 plus 3x equals 9. The next thing I'm going to do is I'm just going to take these like terms and add them together. So my next line of work is going to be 5x minus 16 equals 9. After that, I'm going to add 16 to each side. So my next line of work is going to be 5x equals 25. And then I will need a fifth step. The last thing is I go ahead and divide. So then my answer is that x equals 5. So I just kind of ignored that I already knew the answer, and that's just maybe a good way to double check it at the end because that's what you should get. So I've gone through and listed out all of the statements. Now the only work I need to do is go through and list out 5 reasons. So the reason why I have each of those statements. And if you show your work, I showed my work in blue here. If you show your work, maybe skip a reason step for that so that you have your statement that I wrote in black lined up with your reason. So the only reason why you knew that this was the equation is because that's the one they were given. So you can just write given. There's no other reason for why you had that there. Okay, so then what you need to do is you need to look at like what happened when I went from this first statement to the second statement. And I said this out loud when I was doing it, but I used the distributive property. So what you're going to do is you're going to write out that your reason is the distributive property. And if you want to abbreviate property, I usually use PROP for property. That'd be fine. Okay, and then the next thing was I combined like terms. If you would like to write that out, you can, or if you just want to write out that you simplified, you just want to write out simplify, that'll be fine also. Okay, and then if you did show your work, you probably already know what these last couple of reasons are. When I went from step 3 to step 4, I added 16. So this is the addition property of equality. And this is the way I usually abbreviate that, property of equality. The reason that's important is because eventually we'll get to properties of congruency and properties of inequality, but that's the addition property. And then lastly, I went and I divided each side by 5, so that would be the division property of equality. And there you have it. That is your first 2-column proof. Okay, before we do this last one, I have joke of the day for you. So why do chicken coops only have 2 doors? Because if they had 4, they'd be chicken sedans. Okay, for your next 2-column proof, it is a little more detailed. So go ahead and track along with me. I am going to make my 2 columns. And part of a proof is that you have to kind of explain everything. So that can be kind of tricky for students. Some of these things you're just like, well, I just know why that is. And then actually listing out the reasons is a little harder. So I'm going to start out and kind of walk you through this. Here's what you're given. You're given that angle FGJ. So FGJ is this angle here. This angle is congruent to angle JGK. So those 2 angles are congruent. So I'm going to write out step number 1. We always have to list out the congruent things. I know that it's written right up above, but as far as this being an actual proof, you need to write it out so that whoever's reading through this has that information handy. And I'm also given that JGK, which is the one I just had, is congruent to angle KGH. So if those 2 are congruent, and that was all given, so JGK congruent to angle KGH. So my reason is that's given. I want to somehow be able to link these things up because I want to solve for x in the end, and I'm not going to be able to do that unless I have an equation. So could I say, using the transitive property, that FGJ is congruent to angle KGH? Do you see here I have one thing equal or congruent to a second thing? That same second angles equal to a third thing. So can't I say, because these are the same, that that first is congruent to the last? And yes, I can. This is a perfect example of how we're going to use the transitive property. Okay, something else I was given then is I know how many degrees these angles are, and I want to somehow write this into an equation. So the definition of what congruent angles are 2 angles where their measures are equal. So I know that this probably seems like I'm writing the exact same thing. It almost is, because that's what the definition of congruency says. Congruent angles have equal measures, but I want to somehow make this into an equation that I can solve. And if I have this congruency symbol there, it's not an equation that I can solve. The reason why I can say congruent angles are equal is this is the definition, and I'll abbreviate definition just DEF, of congruency, or if you want to write out congruent angles to be more specific, you can go ahead and do that. But eventually you'll probably just see me writing out the definition of congruency. Congruent angles are equal, congruent segments are equal. That's what it says. Okay, what I can do next then is I can actually use substitution. Instead of writing the measure of angle FGJ, I can say that FGJ is equal to 6x plus 7. And instead of writing out the measure of angle KGH, I know that KGH is 8x minus 5. So here I've used the substitution property. And if you would like to abbreviate it, please don't use SUB because that could also stand for subtraction and that might get confusing. Okay, now the rest of this proof looks just like our algebra proof, so I'll go through this a little bit faster. And again, if you would like to show your work, go ahead and do that, maybe just kind of small, but I wouldn't put that as like one of the lines on here because then it won't be lined up with your statements and reasons. So I subtracted 6x from each side. So this is the subtraction property of equality. The next thing I'm going to do is I'm going to add 5 to each side. So step 6 would be 12 equals 2x. And I use the addition property of equality. I know that sometimes you guys, when you're just solving these algebraically, you do those things as like one step, and I do that sometimes too. I'm going to ask that you write them separately like I did here, so we can give a reason for each one. Okay, then I'm going to divide each side by 12, so I have 6 equal to x. This is the division property of equality. And last but not least, I want to make sure I'm proving that x equals 6, so I'm just going to use the symmetric property to flip-flop the order of those things. I hope this helps, and I look forward to answering your questions.